Hi, this is Matt Danzico, and we're here at NASA Space Flight Center in Greenbelt, Maryland, and we're going to talk about the next mission to the moon. So we're here in a NASA press conference for the LRO, and we're here with Craig Tooley. And Craig, I was wondering, what exactly is the LRO?
Well, the LRO is as it stands for Lunar Reconnaissance Orbiter.
Okay.
Essentially, reconnaissance, as its namesake says, is what our job is at the moon. We're going to do the reconnaissance that we need to design and then execute the manned return to the moon, the human return to the moon. That's our job. Make essentially an atlas of the moon with all the information that's needed to pick safe landing sites, pick wise landing sites, and then know how to build the things that go there.
So what is that going to consist of? Are you going to orbit around the moon for 1 year?
Yes.
And what's the purpose of staying there for exactly 1 year?
Well, we stay for a year. We orbit over the pole of the moon.
Okay.
And essentially, our orbit stays there, and the moon goes through its seasons and rotates around. That allows us to observe the moon in all its, as the lighting and the illumination from the sun changes. We do that for a year. Also allows some of our data sets to build up over a year so that we can extract more information from them. We do that for a year. We fly very low, 50 kilometers, so we get really good resolution with our cameras and such.
Now, from what I understand, there's another project going on called LCross.
Right.
And LCross is going to literally be attached to LRO in some way. Now, what is LCross going to be doing?
Right. The LaCrosse spacecraft, it's a smaller
LaCrosse.
spacecraft. It rides the same rocket. It's attached to the bottom of LRO during the flight to the moon. Soon after we reach just leaving Earth orbit, we separate and go on to the moon. LCross stays attached to the upper stage, the Centaur, they call it, upper stage rocket of the Atlas rocket. It's going to then, it takes about 84 days. It lags us. It flies around the Earth moon once, comes back in, and then it uses that large upper stage of the rocket to crash into one of these craters that's of interest that may hold concentrations of hydrogen or water. That'll eject a large plume. LRO, which is already have established orbit and be observing, we'll look at that plume to see if there's evidence of water or what else. LCross itself, the little spacecraft, will look at it, and a myriad number of observatories on the ground will also look at that ejecta that rises up and then falls back down to the moon.
And what will that mean for the outposts that you're looking to design?
Yeah, the outpost that's planned is planned to be a permanent outpost. We'll establish a presence on the moon, one of the poles of the moon, and we'll have an outpost. Whether we're going to have an extended stay on the moon, which we plan, or eventually extended stays elsewhere in the solar system, from a practical standpoint, you can't do that without utilizing some of the resources. The cost of bringing everything from the Earth is enormous. So water is, probably at the top of the list of resources you would like to find somewhere you're going to live. You can make rocket fuel, you can make oxygen to breathe out of it. So it would allow us to site the outpost very wisely. We don't need to find water to build an outpost, but if we're going to build an outpost, we'd like to build it near water and learn how to use that water if it exists.
Okay, great. Well, thank you so much.
Sure. No, my pleasure.